derivative so far, except
Yes.
what's called U substitution. It's an integration technique that will reverse the chain rule. So if you have a derivative that needs the chain rule, this is how you undo that and anti-derive. Okay, it's called U substitution. You guys all right?
No, they're not.
It was a rhetorical question. Okay. So,
Are you all right?
I'm great.
All right.
Okay, if I ask you to calculate the derivative of that function, how would you do it? Yeah, it's a chain rule question. So, remember your chain rule? Yeah. What's the outside function? Squared. Yep. Power, so. And then we do what? Copy. Okay. And derive the inside. Okay. Right. So we would end up with 4x. Come on, keep up, computer. That derivative, correct? What? It's a power rule. Bring the two down. Oh, subtract one. Well, there's mud, right? What if I asked you to calculate the integral of that derivative? You know the answer, right?
Oh, okay. Plus.
So you know the answer. But if you didn't know the answer, how would you know it? Yeah, it's called U substitution. Okay. With the chain rule, for derivatives, what did you do at the inside? Copied it, so it's already showed up. But how do we get this term here? You derived it, correct?
Yes.
Okay, so we're going to do the exact same thing here. We're going to copy that down and set it equal to U. Right? So just like the derivative chain rule, we're copying the inside. So we set it equal to U. Okay, so now we have this. Correct? Okay, now what else do we do to the inside? Okay, derive that. So the derivative of U is 2x. Don't forget to put your dx. That's the derive the inside. Yep, derivative of U, right? Just like, kind of like implicit differentiation. Okay, what do we have here? It's 4x, correct? But what do we have here? Okay, those have to match. Okay, so how am I going to get these to match? How do I get 4x? Multiply by 2. So I'm going to multiply by 2. To get that number the same. Okay, so that's one little thing that you have to pay attention to. They have to be the same. So these 4x dx is here, correct?
Yeah.
Okay, what am I going to replace it with? That right there.
So where did the 2du come from again?
What comes from where you're inside, you derive it. So we copied the inside here, right? The chain rule. So we take the derivative, we derive the inside. And then to make the 2x match the 4x, we multiply each side by 2. Right? So now we can eliminate this by substitute the. Is that a much easier integral to calculate? Yeah, so what do you got? So and I derive 2 squared over 2. And it's indefinite, so we're going to add a constant. Correct? And that is u squared. Okay, what was u?
X squared plus 5.
So now we can replace it with that x squared plus 5 squared. And we get back to,
All my business.
now why is there a plus c? Yeah, we don't have any integer limits. Okay. What would c be in this case? 0. Okay. So there's u substitution. You're basically backtracking the chain rule for derivatives. Okay.
Wait.
What? Take a deep breath. It's the hardest integration technique you have to learn this year. It is. There's just the step-by-step that you have to follow, which you're basically reversing the chain rule. Okay. Let's try another one without the answer this time. Throwing things at me.
I hit it with the pencil.
He's not going to feel very good here in a few minutes.
Ooh. Well,
Okay, so we don't know what the original function is this time. Right, so you have to identify the inside and the derivative of the inside. Can you do that? The inside, it's inside of something, so which one is it? Yeah. There's your value that you set equal to u. Okay, that's your copied inside. A lot of you are not paying attention, especially in the front row. Tables are more important than math right now. Okay. Okay, now we have to derive that inside, correct? Okay, what's the derivative? Yeah,
other thing.
so fortunately,
They already match.
those match. Okay, that's the key right there, they match.
What if they don't?
If they don't, you have to make them match. It's always a multiplier divided by a number, that's it. The variables will always be the same. The variables have to match. You can't do anything with the variable change. All you can change are these numbers, and that's just a multiplier divider. All right. So now we have sign. Did we mess with sign at all? Okay, but we put u in there, correct? And what replaces the 3x squared? dx. Just the du. Nothing else. That's a little easier. So once you get to this point, you know what to do. It's getting here that you need that you're learning. So what's the antiderivative of sine? Negative. Thank you, Brandon. Okay. And then
We'll do that.
plug your u back in. Substitution.
It seems a little easier when we don't know the answer.
You know, yeah, it could be. There's a little bit less in this one than the other one. So that is your basic u substitution problem right there. Boom. It's just math. If you really want me to make you sick, I'll feed you some maggoty rice or something.
Ew.
Good protein. For all those bench presses you do.
There it is again with the one.
It wasn't a muscle comment, it's a bench press. I'm just making fun of him because that's all I see him do.
That's all he does is he doesn't. I keep hoping I lose my leg.
You lose your legs?
Right?
Like a car wreck.
Oh,
wow. Guess I'll just do the walk around.
Oh, wow. Yes, I just do arms.
I get those like
okay, let's try one that requires a touch of manipulation.
That's not nice.
It's not me either. It's just in the middle ground.
It's just in the middle.
Again, it's a multiplier divide issue. All right, so again, what's the inside?
X squared plus 9.
Right there. And we're not going to write anything else there. So we've copied the inside, right?
Yep.
Now, write the inside.
Do it.
Wait, and then you have to divide it.
Now you have to divide.
Yeah, so these don't match, correct?
Right.
Right, so we need to divide by,
2.
or multiply by half, right?
Yeah.
Who cares? Take your pick.
Wow, it matches.
Right, so we get 1/2. Du is x dx. Now they match. And we can substitute. So we have a half. And what's on the inside here? U to the 5th. That just stays. And then du follows. You see, you have your 1/2 du, and you have your u to the 5th. And again, that's what you're learning, is that process right there, because at this point, you should be able to do that antiderivative.
So where is that?
Why do you separate the 1/2 and
We conventionally put the constant in front of the function.
So you have to get it.
Let's see, it would look weird if you did this. Right?
That's like weird.
No.
Well, multiplication is commutative, so I can move this out front. It doesn't change anything. Right, so I don't bother. Same thing, and it just looks like we're used to seeing it. So what's the antiderivative of u to the 5th?
594.
You can add 1, divide by, right? Okay, now we can simplify, and we plug our u back in, we get x squared plus 9/6 over 12 plus the constant.
Why did you do this?
I don't know what you're talking about.
That's very hard to do.
Good. Should break a sweat.
Holy God, turns last leg.
Again, so summarize, copy your inside, derive your inside, just like the chain rule
Make it match.
for derivatives, make it match, substitute, and then the rest is what we've been doing. And so you have just a little bit of new stuff. We will continue this tomorrow. Who do you think I am? Make sure.
This is, I was like, that's not
Use
16.
two little Swiffer
Yeah.
boxes and then we put a box on top. We're going to
Hey, they're,
45
I think they're good.
My boat had 5. We want every competition.
Just a side note, we've already done those. What would the u value be? What's the inside of the function? 4x plus 1 is your u value here. Okay, but you've already done this. You know that the antiderivative would be e to the 4x plus 1. Since that is linear, we just divide by 4. That's that simple derivative. So you're good here. This is
Oh, that's it? Thank you.
tonight. We'll check it tomorrow. I want you to give these a chance, a try.
Give it a chance.
Give it a chance. That's what I'm saying, there's a chance. Yeah, give these a try. So I understand some of you've never seen. Yeah. You have 110. Wait, I correct that. You might want to 11.
See you tomorrow?
Yes, we'll check it tomorrow.
Oh, that's fun.